Okay, so lesson 4, the exponential function. In this lesson, we're actually going to talk about what an exponential function would look like on a graph. We're just going to use a table of values just so we can get an idea of what the exponential function might look like on a graph. So a pretty basic function would be y equals 2 to the exponent x. And the idea would be that we would try and see what that would look like. So we have our x-axis and we have our y-axis. And what we're going to do here is these are all the different values for x. These are good values to choose because they're close to 0, some negative, some positive. So what we would do to try and figure out what the value is for y, x is -3, so we go -3, but how far up or down do we go? This value needs to get substituted in for x. So to find our y would equal 2 to the exponent -3. So we have to figure out what that is. It's kind of better for this if we just leave these as fractions. So we have a negative exponent right now. So we imagine that's 2 over 1, and then we use the reciprocal, so that's 1 over 2, and that is to the exponent 3. So I would rather, instead of coming up with decimals here, I would like you to do, okay, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. So 1/8. So our point on the graph would be -3 and up 1/8. I mean, we can't really do that very well, just up a little tiny bit. So the second value, if x was -2, now we're going to sub -2 in for where x is up here as our exponent. So we would have 2 to the exponent -2. So we have to remember that's 2 over 1. We don't like negative exponents. We don't want to leave it like that. So that would be 1 over 2 squared. So that equals 1 over 4 because 1 times 1 is 1 and 2 times 2 is 4. Same thing for the next one, 2 to the -1. So that would be 1 over 2 to the exponent 1, and that's just 1/2. So we've got some values here, -2 and up 1/4, not very big, and then -1 and up 1/2, okay, that's a little easier to put on there. 0, so if we have y equals 2 to the 0, anything to the exponent 0 is 1. So this is going to be a really common point on these types of graphs. Then we do y to the 2 to the exponent 1, we would do 2 to the exponent 2, and we would do 2 to the exponent 3. So 2 to the exponent 1 is just 2, 2 squared is 4, 2 to the third is 8. So when we graph here, we would go through 0, 1, over 1 up 2, over 2 up 4, and over 3 up 8. So this is an exponential curve. We've been hearing a lot about that in the news lately. And so as we see something that grows exponentially, it starts off kind of slowly and then increases really rapidly after that. So all we can kind of imagine is that these points would actually get closer and closer and closer to the x-axis, but they would never actually cross the x-axis. So if I had have done a number here, -4, -5, we would have smaller and smaller and smaller fractions as we go. So the idea is, if I was going to try and graph this well, okay, it's going to be hard. We'll come down here, and I'm trying to do a good job. There we go, that's not bad. You can kind of see there. This would continue on forever, but very, very close to the x-axis, infinitely close to the x-axis. So it's going to get closer and closer and closer and closer and closer, but never actually touch it. And then as well, this is going to continue to go up. So I put arrows at the end of each. This actually has a name. The x-axis here becomes, it's called the asymptote. Asymptote. And so the asymptote doesn't always have to be the x-axis. It's just the axis where a curve usually approaches that axis but never crosses it. So sometimes you might have, it could go, the asymptote could go through 5 as well. So if you had a curve that came down and never touched the 5, y equals 5, that line, that would then become your asymptote. So right now for us, the asymptote is the x-axis. So that's kind of all we'll do in this unit anyway. It's just practice, and it's using a table of values. So I could have a fraction. I'm still going to sub in my -3 for my exponent. So y equals 1/2 to the -3. But again, I have a negative exponent, so I would use the reciprocal. I would do 2/1, but then that is to the third. So I don't usually write the 1 underneath. So my answer there is 8. I would sub in 1/2 to the -2. I would use this value here now and sub that in for x. I would have to use the reciprocal because I have a negative exponent, so 2/1, but then the exponent becomes positive. So now that's 4. And then y equals 1/2 to the -1. That's really 2/1. I can be writing these down if you like. 2/1 to the +1, and that's just 2. Again, even when I have a fraction, if it's 1/2 to the exponent 0, that's still 1. So this is going to be another common point here on our graph. I always like to have those there. So then we have y equals 1/2 to the exponent 1. Well, that's just 1/2. Y equals 1/2 to the exponent 2. That's 1/4. And y equals 1/2 to the exponent 3. And that's 1/8. So we could plot these points as well. This is going to look a little different. -3, I need to go up 8. So there. -2 and up 4. -1 and up 2. And then 0, 1. 1 and I go up 1/2. 2 I go up 1/4. 3 I go up 1/8. So this is where our asymptote is, still the x-axis. Our graph would come down. Oh, I want to make it nice, but it's hard. And their asymptote would be right there along the x-axis. So there's our graph. That is y equals 1/2 to the x. So the difference between these, I have a fraction here, and this to me, if I look at that curve, I would say that is decreasing. When I look at this one, so this is y equals 2 to the x, I don't have a fraction here. I have a number greater than 1. And this to me, when I look at it, I would say that is increasing. So just a few notes. The function y equals b to the x, the exponent is a variable. It's x here. Where b is greater than 0, it defines an exponential function. The domain is x, such that x is an element of all real numbers. Does that make sense? So if we look at the x-axis, we're saying that this graph covers the entire x-axis. It's going to go all the way this way, forever and ever. It's going to keep going up, but there still is a little bit of a slope to it. So it will cover that function covers the entire x-axis. So x such that xer. The range is y such that y is greater than 0. So we noticed here that this function never went below y equals 0. And this function didn't go below y equals 0 either, because the asymptote actually ended up being the x-axis. The x-axis is the horizontal asymptote. If b is greater than 1, so that's our example that was y equals 2 to the x. Our b here, our base, is greater than 1. It is increasing then. We look at our graph and it looks like it's going up. And if b is less than 1, our example that we did was 1/2 to the x. It's continuously decreasing, so those graphs look like they go down this way.